I'm not sure whether it is readable. Let's see. This time make sure you select Java application, say any name, any name you can give. I would prefer we don't touch anything, so we'll just go ahead with the defaults because our concern is to see how various type of how various object works and how I can instantiate an object, what is static object, and what is abstraction, what is inheritance, everything we want to see. Just we'll write a simple application, see the output in console, and probably we'll do whatever basic selection is there. So I'm not going to modify anything, simply go ahead with clicking finish. Increase the font size. Okay, so NetBeans created the folder structure, and if you notice, it has put all our source files into a folder called source packages. There is some sort of package lookalike icon is there. Once I click it, I see a Java file, the same name, public class my Java app. Something is left out for me. So this is a typical example. This particular part is actually not necessary to start with until we want to test our class how it works. So this is a typical class I was talking about yesterday. I'll remove the unwanted parts so we'll free up the space. Package is nothing but the folder structure where your Java file is going to be residing. So just for organizing our files and folders. And a typical Java class start with the access specifier, the scope of the class, and the keyword called class, and of course the name of the class. So this is what we saw yesterday. So straight away we can have our objects declared. So if you define immediately after the class definition starts, it becomes a global object. Private mean a global object within the scope of a class. Public mean maybe it's a public object. It can be accessible in anywhere the class has got an instance as well. We'll see that. String. So I was talking about doing this way, having a scope private and data type string. The name of the data type in this case, my name. So it's just a declaration as far as Java. That's what I was talking about yesterday. And it needs a place to get initialized. If I give directly, it gets initialized. So this also one way to initialize. Otherwise, you can anywhere within the program logic you can initialize the object if at all required. So I'm going to write a function void if it doesn't return any data type. Say my function. That's what I was talking about yesterday. Just put a system. I can print my name because this particular object is already it can be used because the object is already initialized. So any function can access it within the scope of this class because it is having a private scope. So this variable can be accessible freely by within the member classes of this particular class, not the other classes. Okay, so now I have a data type declared and I have a function over there. So how do I test it? Whether how this is going to work and how this class can be checked whether it is going to give a output whenever I call the my function. How to call it? Before testing, I'd like to do a couple of other things. It looks like a function because it's having It's been declared inside the class, but only difference is it doesn't have a return type. There is no void or string or anything, and it has a public scope. I was recommending any function should have a lowercase to start with, but this particular function is having an uppercase. This kind of special functions having the same name of your class are called constructors. So constructor for a class is an entry point. You can imagine in such a way for this classroom, the constructor may be this particular door. So through this door, any object can, anything can come inside and start interacting. So you can virtually imagine. I'm not telling that within the door only you should do it. There are various ways to communicate us, and anybody can phone us, or maybe somebody, of course, from morning also they did some sort of alert. So anyway, a lot of ways are there to communicate the data members, but an entry point typically called as a constructor. A constructor, if you do not have anything to be instantiated whenever the class is getting started, you can very well have that. You don't need to declare it because it's already there. But if you have anything to be initialized when as soon as the class start working, you can have the constructor in place. So I'm going to do a little change in my code. This global variable having a private scope within the class, of course, it's already initialized, but this constructor changes its value. So any attempt to access this function, whatever the value I'm going to get, that's going to be, we are going to check using some other way. So if you have a class written, if you want to you want to test it how things going on, that's where um this Java typically comes with a public static void main block. So if you want to test anywhere where you want to test the class, you can have this particular block added. So I'm going to put it back. Argument thing, some sort of square bracket denotes as an array, what it needs. A square bracket along with the data type. We know the data type string, but there is a square bracket followed by mean it's an array of the string. So it's maybe string of array or whatever way you can say. So the same object, it is there in the array format. This particular block, it's like an entry point for your class for testing. We won't use it unless we want to test our class independently. In most of the scenarios we don't use it, but at this point I want to see how the class works. So add this block. Now you have a, remember this block, even though defined within this particular class, my app, there is no relationship between the main block and this particular class. It's just a block independently could be used to test your class. So I'm going to initialize or declare my object instantiated using the keyword new. First point, declaration. It's a local declaration. Remember, within the function I am declaring an object. If I declare outside of this particular function, it would be a global object within the class, but in this case it's a local object within the function called main. Object name, object declared, object initialized. So now the object which got created by initializing, then from that I'm going to access my function, mean this function. So I should get some output. Right clicking, look for a choice run file. It will run and give you an output. So I'm trying to call the function called my function through an instance, create an instance of this class, and from the instance I'm calling this function. It gave me some output, I remember. It gave me the one what the constructor has modified it, because it looks like even though I do not call my Java app explicitly, but initializing itself, it would have called this method first and changed the variable value to this one, and the modified value only gets printed. If I have this particular block commented, I will end up getting this value because there is nothing or nowhere the code modifies the variable. So if we run more time, so I'll get this one. So it's a typical example what we saw yesterday. You can create as many as instances, give a different name. So this is another instance. One has nothing to do with another because this instance name is my Java app 1, whereas this one is my Java app. So run it, I'll get twice because both are having their own instance and printing from their own instance values. So I can have an object declared and initialized, and as many as object I can do. That's the power of having a keyword new. I can create as many as copies. That's what I said. Like your original material, you can take a photocopy and use it as much as possible. Same time, keeping the original unmodified, or maybe keeping the original safe. So this is the strategy here. So we just initialize them and copied it as a into an object called my Java app in this case, or app1 in the second case. From the copy, we are trying to access those methods. That's another simple example. Now I'm going to write a couple of another method, so another class. Some name my base class because I'm trying to explain inheritance. I'll just remove the unwanted parts. As usual, this class also I'm preferring to have a constructor in place if required. This time I'm going to have a static method. Sorry. Printing from a static function, that's what I have written. It is a function, but it is having a static keyword prefix. So what way it is going to make a difference? So I'm going back to the previous class called my Java app, because that's where I have a public static void main defined, because that's the entry point for me to test. So I'm going to use this block for testing my code. So the same way, I'll try to see my base class same like before. So this, even though it is a different class, but I can safely access because all belongs to the same package. So I declared an object called my base class having a lowercase m. So this object is going to have an instance of my base class, the particular class. Now this is also having a public scope, print name. So first thing I would like to see I can do it, but it's showing some sort of warning. If you notice, it's trying to say something to you. So replace with the class reference what it's trying to say, this is probably not the best way to call a static method, because the method itself is static. You don't need an instance to do the job. So what I can do, I don't need an instance, I can directly call it. I don't need a keyword because it's all intrinsic value, it's the original copy. So if a static thing is there, all I need to prefix the class name and directly call the function name if a static keyword exists, if not possible. So let me try to run this code. So I'm getting the output from the static function as well. So anywhere if you find a function having a static keyword or an object static keyword can be directly accessed, we don't need to have an instance to access that particular object. For example, it could be this way also. An object can also have a static prefix or keyword, so it can be directly accessed. Of course I need to print it off. So I can directly access to and get the value because it's just an object name. Typically static variable we won't prefer as much as possible because it's even though it's fast, but chances are there it may become a potential violation if a code becomes so bigger, and anywhere if a developer or some other developer modifies the logic, it will impact everywhere wherever the static object being used. So if you really want to protect the static object, mean if you really want some sort of constants, what you can give a keyword called final. This will make sure your static object cannot be modified. In other words, anything could be modified what we call variable, anything could not be modified what we call constants. So having a final keyword makes this particular object a constant because this value cannot be modified. There is no way to modify it. So what I will do, I'll have two objects. One, I'm not going to keep a final keyword. So 1, 2, I'll keep it. Anyway, this guy will throw an error. I'm trying to change. First thing, it's showing an error first. Second one also I'll print it because that's also a static object. But the second object doesn't make any error. So it can be, so now I change the value. Let me print it one more time, both the values. Whereas one is showing an error because the reason is cannot assign a value to a final variable because it cannot be modified. A static variable, even though, but it has a final keyword attached, mean once the value is assigned, cannot allow the value to be modified if you provide the keyword final. So final in terms makes the particular object a constant. If you do not put the final, the static object can be modified anywhere in the code because the static object can be freely accessible using the class name having as a prefix. You don't need to have any instance or anything else. So in this case I cannot modify, of course I cannot run this code, but let's see the other one gets modified. If you notice, the first two value unmodified one, the second two value, the second object a name 2 has got modified. So the static variable has got modified, it become permanent. Since I modified, naturally you need to assume this is permanently having the value modified. So mostly we will use a static object. We'll have a prefix. I mean, we'll have a keyword along with the final also, because uh, I I may be using the static object wherever if I need a constant in place. So constants typically we have some sort of convention to define a constant. I always use all uppercase letter if I use constants. It's nothing but a static object having a keyword final. The moment I notice anything all uppercase comes in, it is nothing but a constant, so I can easily understand. So it's a naming convention where I always follow. Of course, this is all developers follow. So it's all a class will always have uppercase and follow the camel casing system. Function will always start with the lowercase. Of course, it will still follow the camel case system. Whereas a constant will have all uppercase, so that it simply tells us, okay, it may be a constant. So we may be wherever if I notice, okay, uppercase letters are there, mean that particular object here, of course, naturally a constant. So I can easily understand, okay, there's going to be a constant object. So any attempt to modify is not going to be allowed. So I can easily understand. I won't do any other step. So this practice I would recommend if you are defining a constant anywhere in your code, make sure it's all uppercase. Okay, so that's a small difference between having a static in place. Of course, you can have other methods. Um, in this case, I haven't put a static keyword. I'm going to say a non-static function. So can I access? Of course, if you really want to access, you need an instance, because not like this way I can directly access. I may need an instance of this class. So it will only allow the access of the method through an instance only. It won't allow you to directly access like before, because it does not contain the keyword static in this case. So if you try to access directly, you will end up getting an error. So I'll try to access them directly. So I'm getting an error stating that non-static method cannot be referenced from a static context. So that can be accessed through an instance. Okay, so printing from a non-static function. So be careful where to use static, where not to use static. So typically I won't recommend on, if I see it also static methods, I won't have it even in my Android coding. As much as possible I'll try to have it, because having everything through a static may be powerful and easy and fast, but in longer run, if a code logic becomes so complex, uh, there may be potential issues if other developer comes into work, or you yourself catalyst. I mean, maybe in so you did not notice, you commit some sort of mistake, will impact everywhere. So we won't use that, but still for our understanding, what is static and non-static option we just saw. So the same applicable for object also. If you really want to access this one, you have to make sure through the instance only you call it. Sorry. So there is a difference. Remember, say I have upper and lower case, so that very clearly tell the class is directly referenced, mean this particular object is a static one, but the particular object access through the instance mean it is a non-static object, and same applicable for functions also. So functions and methods, if any keyword defined as static, then it can be directly accessed. We don't need to have a kind of instance in place. So this is the difference between the static and non-static. Now I'll move on to another example. So my data, whatever. I'm trying to create another class. Here, I'm going to declare a private objects. Remember, just a declaration. I'm trying to define an encapsulation in place. So this particular class contains various objects declared, but having a private scope. So within the class, within this particular class, any function can have the particular methods to be accessed, or particular object could be accessed. But first thing, it has not been initialized. I'm going to go here. I'm going to do my data, initializing it. Okay. If you want to set what is my data, I want to set a first name, last name, subject, roll number. In this case, I cannot set anything because the scope of the variables defined within this particular class having private scope mean it cannot be exposed outside. We don't have option. So say first I will end up getting error saying that first name package private, or it's not actually detecting. It's saying it is assuming there's going to be some sort of package exist, but it is not taking it. So if I really want to set the data, I can use some sort of tricks. Like that, you need to have set method or setter method, we often call. Set is just for my understanding because I'm trying to set a value. So I make this method as a public scope, so that through this method the value could be set. So first name is equal to f name. So if I put in this way, this particular example, my data set first name. Now I can set the value. It's like where this particular value is setting, nobody knows, because that information is protected here. Using a method, all you need to send it, that will take care of assigning the value to a specific object. So we just hide the logic behind it. And also helps us to denote the whole student record, in this case looks like a student record, as one single object called my data. So I can group the different objects together and denote them as one single data type. That also it does, and also protect certain data members, and how the value is being assigned through, it gives access only through the methods. So in that way it becomes an encapsulation, or it hides the logic what is behind it. So I can create a method called public void get full name, which is return type. Maybe the return type, when I put, you need to put a string, because the void won't work because you are trying to return something. So first name plus space. So it's another way, you when the value of a first name last name set, you can add one more method and try to use that method to retrieve the full name after duly setting the first and last name through both setters. So you can create various hidden formulas here, try to make various combinations. Nobody knows how things are working within the class. All they know, there is a object called my data which will take care of whatever logic what I'm going to write, that will do the job. There is a easiest way to automate this task also. If you are very tired to write all the bunch of methods, all you can do, source, I hope it is insert code getter generate. It will create it for you. You don't need to write separately. So setter. So those methods will be automatically added if you really want. So get set mean setting the method through this methods and getting the value from it directly. It automatically create the specific variables. Remember, this is a local variable. This denotes it is accessing a global variable defined in this class, nothing but this one. So this main instance of this class, so typically a kind of instance of the same class what we define, this is called the keyword this. So because since the name looks like a same, one of a variable is coming from an argument, another variable where you are trying to set the value is also having the same name, I need to differentiate it. So telling this variable is actually defined in this class as a global one. The one another one is nothing but a local variable belongs to this particular method alone. So this a keyword, it tells instance of the same class. So this main instance of this class. So I can, in this case example, so an object created which contains the bunch of students record, so one particular single student record, but it's still denoted as my data. You can create as many as instance. For example, the first set is this one, second set. Remember, the moment I call new, it will erase the previous one and create a new instance. So I can have another one, say something. Like that I can have the student, but I'm not saving anything, so as of now I'm not going to worry. But the only thing I would like to tell, an object can be created to group a set of data, one, and the object could be protected, and of course the access to an object could be given through setter getter methods. So setter method will try to give a value to an object, getter method will try to get the value from the object value whatever it's been set. You may wonder why we need it. We have extensive use of it. That's what I said. I gave a small glimpse of usage, like I can write some other method by making a combination from first name last name. For example, I can convert everything. Say first name, last name, subject. I cannot put the roll number because the array type is a string. So, so if I simply get a value from, it will automatically get, it will convert every individual object into an array. I don't tell how I form the array and which order I formed, which data I use to form the array. I don't need to inform it, but I simply give access and try to give an output. So I can create various different combination or maybe hidden methodologies to create a complex data type. So I can hide the business logic behind it and restrict the usage of the object also for outside classes or outside environment. So that duly encapsulate everything. So this particular class does the job of encapsulation, and also this class helps us to define a group of attribute values to a single entity. In this case, my data has various values stating that first name, last name, and roll number, subject, or, and still it is a single data called my data. So that's way it used. So if you want to compare to the JavaScript, what I was calling is JavaScript object. You remember we had a key and value pairs. So in this case, it looks like these guys are keys and the values which is going to hold inside. So similar to that. So a setter getter method can be put into use, and the same object can be reinitialized, but if we are using the same object to reinitialize, remember this entire data is gone and it will have a new copy and you define a new one. If you want to prevent having this particular data to be protected, what you can do, you can reinitialize with a different one, getting then my data 1, modify it, have the different instance. So in this case both will reside in the memory, so it won't get deleted. That's what I was talking. And in fact, the new keyword, it not only create an instance, it will also make sure it erases the previous instance if anything is there, reinitialize. So freshly keep a copy. Fine. So this is an encapsulation. And another one, my parent class are trying to do inheritance stuff. So print name, will keep it. What's that? This is a standard class. It has some sort of functions inside. Now, this is the first one. This class going to inherit everything from extends is a keyword for inheritance. So in this case, the way I use the keywords, my Java app extends from a class called my parent class. It means my Java app, it has its own list of methods, but also carries methods defined in my parent class also. So it means this one is a bigger one. This particular parent has got joined with this particular class. So inheriting start with the keyword extends. It means, remember, I haven't made even a single instance of my parent class in this code. But whereas I have an instance of my Java app already, I can freely access the method name called print name because the print name actually being defined here. But it is there in the parent class. But without any issues, I can directly call the print name. Remember, there is no name print name in this method. But so this particular print name is belonging to a parent class. But right now both have got merged. So this object has also have an access to this particular parent class also. So trying to print will also give printing from parent class. Okay. It not only gives this opportunity, this guy also get few more options. So name I forgot. I put some lot of things I removed. When you inherit all the properties from a parent class, you not only get the access to a object and functions of the parent class, but you also get a privilege to modify its behavior and add something to it or change the way it works, the various things you can do. So in this case, this particular child, my Java app, inherits everything from a my parent class. Fine. I even accessed it without any, additional code. But this guy does some more thing. It is having an override annotation because I'm trying to override the parent class behavior now. I'm going to change the way it is going to work. What I will do is, first thing, when I try to have the same name, same signature, same format of the same name of the parent class, it becomes a overriding. Right now it may not be mandatory, but it is recommended. Mean it tells this method does not belong to this my Java app class, it belongs to a parent app class, this guy try to modify it. So having override would be helpful, and it also helps us to identify, okay, this class belongs to a parent class, or the class it belongs to a class where it has been inherited. And the super dot some the same name tells it, in this case, make sure you execute everything in the parent class, in this case this line. After that, add additional lines. So in this case, couple of line has been added by this child class. So the super tells finish whatever lines are there in the parent class. It means print this line and then add additional line. So now if I try to run this code, because this function is already calling print name, I get two outputs, one from parent class, second additional lines added by a child class also I get, but even then I try to call this one single function. To make it clear, I'll comment all the lines of code. First one, printing the particular value or particular console output actually was printed from the parent class, because we notice my parent class contain, what happened, source, okay. So it has the console output from parent class, so it made sure it printed the value, and after that the modified behavior has also been printed. If you try to change the placement of super, automatically the order will interchange. It means the first precedence would be by the child class, later only the parent class would get added. Let's see that also. Sometime this will have a, if you see, the order slightly got changed. The modified one took place first and the parent part happened little later. So the order could be changed based on this placement of the super. Mean it, you tell, for example, first let the parent class execute, then my additional line could be executed. That was the previous case. In this case, you're telling first add my lines and then allow the parent class method whatever lines are then executed. So this is one small difference. Override annotation helps you to identify this method belongs to a parent class, and any attempt to modify, I mean, you have implemented the same signature, same method, so your intention is to modify its behavior or add some more lines to it. So if you really want, you can do it, otherwise simply leave it. And only public methods could be modified in this way, overridden. Any private methods are there in the parent class cannot be accessed. First thing, it's a private one, not used, it's very clearly telling. First part, I cannot even know whether such a method exists. A private, see, no choice suggestion itself, it's not coming. I cannot access it. Nor I can modify its behavior. I won't get any suggestion because this particular method is having a scope private. A child does not know whether such a method exists. But I can still put into use. The parent indirectly give a benefit of this particular method through one of its public method, but it hides this particular method to the child. It means it doesn't allow you to modify, but still allows you to use the particular method. So in this case, I call this function in the print name which one of a public method. If you notice, the output also will be printed, but nor I cannot change the behavior. We run the code. So that output is coming, but I don't know from where. And of course I cannot modify, I cannot change any line, I cannot add few lines to the particular function, but I can still use it. So inheritance in such a way, a public access specifier opens the privilege to a child class, so it can modify its behavior, override the method. So it's called method overriding, changing the behavior of a method. And there is one more option, method overloading, that we probably will see it a little later. So this is a simple example for your inheritance. Let's see some example on abstraction. Trying to create an abstract class. Abstract class typically have a keyword abstract. Abstract classes mean it is an incomplete class. Mean one of a function or all the functions does not have active body. The class is incomplete. That's what we were talking about. Yes, it's a component. It has some sort of working body, but it only gets a particular shape or it put into use only when it get connected to a particular interface or somewhere it gets connected. So an abstract class typically an incomplete class. Remember, it's still a class. Means this is a typical function, but this function is incomplete and also have a keyword abstract. It means there is no active body like curly brace, because if I put also it will going to say me an error because I put the keyword abstract. Mean one of a class, of course it has two functions, but one of a function is incomplete. In a class, if you put even one single incomplete function, the whole class becomes an abstract. So that's very important point to be noted. If in a class, for example, I have a lot of class in this case, say this my base class, it has a bunch of functions. The moment I add some sort of abstract method, of course I should not add this. The moment I add abstract method, this guy will start showing an error saying that, hey, you contain an abstract method, the class itself should become an abstract now. So in a fully qualified class, even one single abstract method is found, that whole class becomes an abstract. Mean it's an incomplete class. It cannot behave independently. It does not have any quality to get inherited. Nothing. So it's same like a kind of a component waiting to get it attached to a parent or somewhere else. So if you put an abstract method, the whole class becomes a abstract. And of course, the abstract class can also have a fully qualified functions also like normal class. But only thing, one single function or one or more functions having an abstract, feature, then the whole class become abstract. So how do I use this abstract class? An abstract class typically useful for connecting, interfacing, linking. So that could be done using implements. So that should be an interface. Okay, I'll do on this. For testing, we'll keep the same method. I'll write one more method for this, because inheritance we need this example. I'll use one of existing class. This class is there. So trying to extend abstract class. Now this particular incomplete class has got attached to one of a class here, but still when it get attached, this guy started throwing an error. How do I remove it? Simply click on it. It tells implement all abstract methods. So this particular class contains some sort of incomplete methods. Please give a place to implement it. So once I click it, automatically this unwanted line stuff I'll remove it. So unless I have this particular block added, this particular part won't work at all, because you're trying to inherit an abstract class. This class cannot work independently, remember. But whereas this particular parent class what we had previously, it's a fully qualified class, it can independently also work. But this particular abstract class cannot work independently. It should work only through some sort of child class needed, so where it can have these abstract methods to be implemented. So in this case, this my base class has become a child for this class, but it gave a place to this particular abstract methods to get implemented. Now, by implementing its method to a child class, this particular class attained a fully qualified function in this case. So without having this particular method, the inheritance never get completed. So an abstract class, remember, it would need a place to get implemented. Otherwise, this won't work. And of course, an abstract class having one single abstract method make, of course, entire class an abstract. So we may use this kind of abstract methods to define a blueprints, saying that if I want to have some sort of operation to be done, for example, uh, if you really want to open a hotel, uh, what you there should be some sort of minimum requirements saying that, hey, a kitchen, number of tables, or some electricity, gas, everything. So if you want to define a blueprint for something, uh, whoever try to have some sort of object implementations, you can define a blueprint as an abstract class. So anyone try to have that particular object implemented will follow their blueprint and make sure it respect all the required thing added to it. So abstract class, we may be using them to define a blueprint, define a rules, regulation or something, so that if you attach abstract class, these methods should get implemented. Otherwise, you cannot use it at all. And also it can have its working body and it will still work. If you really want to have a, that's what I was talking, for a car, if you want to have a headlight, the headlight should find a place to get inserted, and also there should be a power probe should be connected with the car, then only things will work. So for a headlight to be added, there should be an option, there should be a connection for a probe to get connected with the car, so then only the particular thing gets connected. So for a car, if you really want to have a headlight, you should give a provision to get the particular connector to be connected to a power source. So like that, to define a rules on blueprint, we can make use of abstract classes. So probably only one left. Final one. Interfaces, kind of still abstract one, but this is going to have a keyword instead of class. It's going to have an interface. Interface also, there is a very lesser difference between the interface and the abstract class. An abstract class uh, may or may not, may have fully functioning classes as well as an abstract methods. I mean, fully qualified functions as well as abstract functions. An abstract class can contain. So in this case, abstract class has a fully qualified function and also contain an abstract function. Whereas in interface, only abstract methods only allowed. Mean a method should not contain any body. You cannot have a fully qualified functions anymore. So that's a plain difference between an abstract class and the interface. Of course, that makes a whole lot of difference the way it is getting used. So for example, if I try to put it, this guy started putting an error saying that interface abstract method cannot have a body. Means you only have an abstract method, you cannot have a body. So typically, I don't even need to have a keyword abstract because only abstract methods are allowed. So whatever method you put or function you put, of course, the modern day people are calling it a function, should not contain any active body. So if you have an interface, mean it is going to have only abstract function. It is not going to contain even a single fully qualified functions such as we found in abstract class or normal classes. So that makes a difference here. An abstract class can contain fully qualified function as well as an abstract function. But whereas an interface will only contain abstract functions alone. So, oh my god, it just got disconnected. Okay. So how do I use it? It's already having an abstract method class. This kind of interfaces typically useful for connecting. Uh, of course, abstract class also doing the connection job, but this is exclusive for connection alone. For example, my interface. It always follows a keyword called implements at the end, nor it takes a keyword extends. Interfaces always gets implemented with a keyword called implements. And class name, of course, it's throwing an error, and it is saying implement all abstract method again. If you notice, the same way what the another method got implemented while I tried to have an abstract method, say abstract class in place, the same happened here, and the particular function which I defined in the interface is got implemented. But now in this case it attained a fully qualified body. For example, this function is ready to be used. So normally this makes a whole lot of difference, because an abstract class, even though it cannot work as an independent class, but it could be inherited. Mean somewhere it has a active working body, and finally it has its indigenous standalone working body, and then it only needs some sort of help from a child class, and then when it gets connected it starts working. That's why I gave an example of a car and the headlight. Headlight mean it's a abstract class in your word, because it has all the provisions, connector, wire, in fact the bulb or whatever, but only thing it needs a power source. So it is doing everything. It has all step down, step up, transform or whatever. I don't need to say that what how things been made, but it has some sort of connection. It does some sort of work, but the only thing it need help of a connector, so that it needs a power source so that it can start working. So an abstract class is like that. It has a working body also, but only thing it cannot indigenously work because it just need a connector, or somewhere it need a power source so that it can start working. So that's an abstract class. Whereas the interface, it just does the connection job. Mean two different classes exist, mean it just a probe, just a connector alone you need to think. It just bridges two different entities and makes a connection between them. Nor it contains an active body, nor it doesn't indigenously work. It cannot be independently put into work, but it can only do the connection job. How it can connect? In fact, we are almost close to get it connected, but I would prefer one more example for that, how the connection is happening. When I explain the connection, I need to tell where this kind of scenario needed. For example, um, in your car itself, if you want to consider, there is a huge complex parts exist. It means uh, your accelerator starts working only when the car has been started. It's switched on, or maybe you put the gear, or probably you have your key inserted and put it into a neutral, and then you need to change the gear, then only your accelerator takes in charge. So one has a dependency over another, and in fact all are working independently in this case. So I need to make sure certain processes are completed so that this particular process can take over the job. So two different indigenous processes are there. For example, switching on the vehicle, making sure your fuel is there, making sure the motor is switched on, then the gear will take on the control. So who will inform them? Everything is ready. Hey, car is on now. Engine is started. Gear is in neutral, and let the accelerator start. Who will inform them? This kind of interfaces will do the job. We'll take the information between the various processes and inform them and have the particular job done. That would slightly require a little more explanation. Probably I will explain that tomorrow. And along with the way, we will start what is Android development. Hopefully within that time, we'll have our Android Studio and other SDK parts installed in our computer. So we can do that probably in the morning time, but I will explain about the interfaces with some small example. In that, I'll also introduce what is Java threading, what is processing, because that's slightly complex. Because I now itself I told you there are various processes involved where the interfaces would be useful for us. So once we identify the usage, then we can start the Android development. Of course, these things again going to repeat, but that time the context is going to be Android. Now I just explained in a very plain word. I did not give you a much scope, but there we will have various scenarios, and we can perfectly test all the properties of the object-oriented technique. So we'll see that. Okay.